Hello friends, in my last video I explained you about the relation and today I am going to explain the function. What is function? Actually a function is a special type of relation. Here we learn when a relation is said to be a function. Okay, let us take two non-empty set A and B. These two non-empty set A and B, now the elements of A and B are related by a relation f. Now this relation f, when it is said to be a function, this is under two conditions. Number one, if each and every element of A has an image in the set B. That means for all x belongs to A, there exists at least one element in that set B which is an image of this set of this element. So the first condition, every element of A, what are the elements? Suppose x1, x2, x3 dot dot and so on, so many elements are there. Now for each and every element there should be an image. Now second condition, the image should be unique. That means every element has just only one image. Suppose if I take fx1, it is the image of x1. fx1, it is the image of x1. Suppose this is fx1. Now the same x1 has another image. Suppose this fx. That means this fx and fx1 both are image of x1. Then we will say that the images are not unique. So in that case the relation is not a function. Now what we can say in that case, suppose fx1 is equals to fx equal to fx, then only, that means these two supposed to be the same element, then only we can say that the relation is a function. So I repeat, the relation is said to be a function. First condition, that each and every element should have an image. Second condition, the image should be unique. If it is found that the element has two images, then that particular relation is not a function. Now I am going to take some example to explain this relation, that which are function, which are not. Let me take, suppose y is 5 times of x, that is y equal to 5x, y equals to x square, y equals to square root of x. Now out of these three relation, we will find out that which are function. See, whatever I am taking, suppose x belongs to, all this x belongs to the set of natural number. Now whatever I am taking, y also will be a natural number. Suppose x is 1, y is 5, x is 2, y is 10. So for each and every element of x there is an image, and that image is unique. That means there is no such element of x for which we are getting two values of y. Suppose if I take x is 5, then y will be only 25. No other value is there. If I x is 10, then y is 50. That means for every element belongs to A, the image is unique. Number two, for whatever I am taking in this set of natural numbers, suppose x belongs to natural number, then if you multiply that natural number by 5, there also will be another natural number. That means each and every element has an unique image. Now let us see for this. Suppose this belongs to set of natural number, whole number, real number, whatever be. If I take x is, suppose x is 1, then y is 1. X is 2, y is 4. X is 3, y is 9. X is minus 1, y is 1. That means there may be, suppose if I take x equals to 1, for this relation if I take x equals to 1, then 1 square is 1. If I take x is minus 1, then minus 1 square also 1. That means both of these two have the same image, but none of them has more than one image. Say x equal to 1, it has just only one image, one only. X equal to minus 1, also it has just only one image. Suppose x is 4, then 4 square is 16. The image of 4 is 16. So each and every element has an image, and that image is unique. So this is also a relation. Now for this, suppose x is 4. If I take x is 4 under this relation, say x is 4, then the square root of 4 is what? Plus 2 or minus 2. So the element f x is 4, it has two images, 2 and minus 2. So whatever I'll get here, if x is a positive real number, here we'll get another real number, but for every element we'll get the image, but the images are not unique. Each element will have two images. 4 has two images, then 16 has two images, 16 also has two images. It is what? 4 and minus 4. If I take 2, it is also two images, plus root 2 and minus root 2. So each and every element has more than one image, two images. So images are not unique. So we can say that this relation is not a function. So y equal to 5x is function, y equal to x square also function, but y equal to root over x is not a function. Here I am going to take a graphical representation and we will show that whether it is function or not. Suppose this straight line. For each and every values of x, there is an image. Whatever I am taking, suppose x is 1, we will get a particular value. X is 2. So each and every element has a unique image. So this is a function. But now if I take, suppose this, say this is the relation. Now is it a function? See, for this particular values of x, x1, how many images we have? 1, 2, 3. So images are not unique. So this is not a function. This is a function, but this is not a function. Now I'll explain you the different types of function. First is the constant function. Say fx is constant. Constant means it can be any value. Suppose fx is 5. Fx equals to 5. So whatever we'll take x, fx is always 5. If we represent this, then so this is fx is 5. For this fx5, the graph is this. It is a straight line. Now whatever I am taking x, for each and every values of x, there is an image. See, for x equal to 1, it is 5. X equal to 2, it is 5. X equal to 3, it is 5. Whatever x I am taking, fx is always 5. So it is a function and it is called the constant function. Now identity function. If the function, suppose fx equals to x. Suppose x equals to 1, fx equals to 1. X equals to 2, fx equals to 2. X equal to 1, fx is 1. X is 2, fx is 2. X is 3, fx is 3. That means the function is related with itself. If x is minus 1, it is minus 1. X is 2, fx is minus 2. So each and every values of x, there is an unique image. So this is also function and it is called the identity function. Now modulus function. Fx equals to mod x. This means that fx is x when x is greater than or equal to 0. This equals to minus x when x is less than 0. This is called the modulus function. Here is also whatever I will take x, fx is always positive. Either x is positive or negative, whatever, fx is always positive. Okay, let us take, say x is positive number, x is plus 1, then it is fx is 1 only. So for 1 it is 1, x is 2, it is 2, x is 3, it is 3. Whatever I will take x, fx is same. That means it is identity function for this part. F is equal to x, identity function. But now if I take x is less than 0, suppose for negative, then suppose minus 1, then minus of minus 1 is plus 1. So for minus 1, it is plus 1. For minus 2, minus of minus 2, that means it is plus 2. Minus of minus 3, it is plus 3. So whatever I am taking, x either positive or negative, fx is always positive. So it is this function. So here is also we are getting another function. Here we will see that for each and every values of x there is an image, and this is called the modulus function. Now the greatest integer function, fx is equals to greatest integer function, means suppose here I am taking x and this is fx. Greatest integer function less than this x, suppose x is 0.1. Now what is the greatest integer which is less than this 0.1? It is 0. So for x is 0.1, fx is 0. X is 0.2, it is 0 only, because of up to 0.9 or 0.99, very close to 1. Very close to 1. Suppose here I am taking 0.9, then also the greatest integer less than this 0.9 is 0. Now if I take 1, then the greatest integer less than or equals to this is 1. If I take it is 1.1, the greatest integer less than or equals to this is 1. So till it is 1.9 or very close to 1, it is 1. But as soon as we are taking it is 2, the greatest integer less than or equals to 2 is 2 only. I hope all of you understood. I repeat, starting from, let me represent this on a graph, then it will be clear to you. Suppose if I take x is 0.1, 0.2, 0.3, 0.4, 0.9, very close to 1 but less than 1, then these are all fx is 0. Why? Because of this function is the greatest integer less than or equals to x, that will be fx. So whatever I am taking from 0 to very close to 1, these are all values of x. For this all values of x, fx is always 0, because 0 is the only greatest integer which is less than this number. But as soon as I am taking 1, then fx is 1, because of it is the greatest, 1 is the greatest integer, 1. Now if I take 1.1, then less than 1.1, greatest integer is 1 only. So this 1.2, 1 only, till 1.9 it is 1 only, very close to 2 it is 1 only. That means the graph is this. But if x is 2, then fx is 2. X is 2.1, fx is 2 only. Till 2.9 it will continue the same value 2. Fx is 3, now x is 3, now fx is 3. This. Now this side, if I take x is suppose 0. minus 0.1, so the greatest integer which is less than minus 0.11 is what? Minus 1. So it is this. Then minus 0.2, minus 0.9, whatever I am taking, the less than greatest integer is minus 1 only. That means it is, now as soon as I am taking minus 1, it is minus 1, but it is minus 1.1. If I take x is minus 1.1, then the greatest integer less than this is just minus 2. So for minus 1.1 it will be minus 2. This is minus 1, this is minus 2. So for less than this, all these image should be minus 2, minus 2, minus 2, minus 2 like this way. So this is called the greatest integer function, or also known as the step function. Why? It just look like a stair. Now last function that I am going to explain is the trigonometric function. Suppose fx equals to sin x. This is also a function. For each and every value of x, there is an unique image. Let us see. X is 0, sin 0, it is 0. Suppose if I consider only this range, see, whatever I am taking, x is pi by 6, x is pi by 4, x is pi by 3. For each and every value of x, there is an unique image. See, for each and every value of x, there is an unique image. That means we can say that this is also a function. So here in this video, just I explain about the function and the different types of function. Thank you very much.